we're going to review the extreme programming and Scrum, right? These two methodology are agile, right? So last week we talked about the agile methodology. For extreme programming, we need to have a smaller group of high-scale professionals. No matter what the technology is, that they can grasp it and tackle it in a very short time, right? So extreme programming is very hard to form. Usually the client, right? Client need to have a very new system. They may not find it all the time, right? So they will ask for bits, right? They want some company or the team can design a very special system, right? It needs very high scale, and they don't want to wait for so long. Then if a company can hire a group of high-skill professional, well, they will use extreme programming methodology, to get a bit. Right. So the group of professional, of course you got to pay, very high, so they got a high salary. But the customer will discuss with them, right? Because the customer may not have the clear picture of what they want to do. So they involve in the daily discussion of their meeting, right? The customer wanted to see the progress and leave the room for the professional to design, all right? So they involve a lot. They usually will hold it. It means otherwise the professional may go wild because they like to tackle, they like to change, they like to test their ability, technical ability, right? So customer just wanted to see how's going. Oh, okay, I'm fine. Oh, no. Probably they needs, it's a lot of budget to do that, right? So, well, it's very efficient to design that because the professional, right, technician in the team, they work together and can deliver the project in a short time, right? But the customer need to keep an eye on it, otherwise it go wild. And the other way, Scrum is more popular, adopted in the organization, the company, because it's more stable. They will not go wild, and the member in the Scrum not necessary to be high scale. They need different kinds of professional. And the project, you have a product owner, right? Discuss with client, right? Not that often, like extreme programming, they involve a lot. But discuss with that and get the idea and list what product we need to design and tell the member, right? Those are the product the product we need to design. And they will have a scrum master. Scrum master is not a technician. It's going to negotiate between the members, right? No, that's and with product, the product owner. Every task, the task from users' requirement. So we can see user story the same as extreme programming, right? User story is very plain language. Then based on the story, they list the task and the schedule, right? So the sets very intense schedule. If a task, right, they set it for probably 10 days. So you got to finish that in 10 days. But a team discussed that, well, we estimate that we can finish it 12 days, but it says 10 days. So they got to follow that, right? So got to squeeze that to, keeping, progress to fit the deadline. So usually the deadline was set very intense, all right? So that's why a company, let it adopt Scrum because they got to set the table. Just tell them, tell the product owner, I want the task, all right? And discuss the whole project, right? The whole project got to finish that probably in 8 months, 1 year, or and also you could see Scrum of Scrum, right? A very big Scrum, a Scrum of Scrum. So that's quite a difference between extreme programming and Scrum, right? So for professional, of course, extreme programming, better than Scrum. For everyone, not Scrum, right? So everyone in extreme programming in a small group, they can tackle very difficult problem, right? They can, because they are all experienced programmer, right? And usually they will go wild. I said that go wild, go uncontrolled. So the customer need to, like monitor them, right? The progress that's, oh, no, not that, right? And that's going to change that. That's the difference between these two. So that words, you can read that by yourself. And the process. Okay, so we will discuss the process, and so now we know the methodology. So usually it says the paradigm, all right, the change. So by paradigm, you can see that procedure paradigm. Procedure means process oriented, right? Later we'll discuss DFD, right? Data flow diagram. Data flow diagram, that is process oriented, right? Data oriented is data centered. ERD, right? So entity relationship diagram, so you're going to see that ERD, process oriented, combines process and data together as one. That's object oriented paradigm, right? And today we talk more about the process oriented, right? We will introduce some symbols and how to draw the diagram, right? So on the left side, the right left side, right? It's going to see that that is the diagrams DFD, right? And this, that is, we have the, as again and Samsung, right? Again and Samsung and Jordan. So you're going to see we have to later, okay. Again and Samsung and Jordan, we have two. This is one. So you can see we have external entity, customer, right? Customer is going to ask for something. Ask for invoice because customer wanted to order. So we know that yes, wanting to process order, right? So, but here you can see the circle here. But should not be process order. It should be order system. All right. That the no, the picture here, that's not correct. Right. The circle, you can see the circle should be order system, right? And tell us this is the order system and needs customer. This is one piece about customer, and we have a data store. We have two data stores here. Okay, sorry. I gotta say that's this is a process order. Okay, process order, but we have more processes. This is one piece of that. I gotta say that one piece of that. So I modify what I said. Right. This is order system, right? But we go to our system and we can see that one of our entity is customer. Entity is going to send order, right? To submit order and receive an invoice. It's only piece of that. You say only piece of that. So what of the process order, right? Could have other. And then, so that's DFD, right? And the middle one, you can see in the upper, that is sort of the problem domain. So if we wanted to design a system, it's banking, then the banking is our problem domain. So it depends on the domain. You have the the templates, right? Class. So this is a class diagram. We can see the relationship between the class, right? So here we have two relationship. So one is inheritance, the other that's aggregation, right? So you can see the relationship, and the right hand side is ERD, right? So you see entity, ER, relationship diagram. So students, course, have a relationship with enroll, right? And student has its attributes. No. So that's the course, right? And you also can see structure that's the lower parts. So it's a hierarchical, right? So hierarchical structure. A structural design that is static view. So it's the static, not dynamic. But when we go to dynamic, right, so object oriented, so you can see it's a sequence diagram, for example, here. So you have actor, right? Actor is external entity, right? This is called actor, and the object, right? Object's top level, and the sequence of their message sent. And on the right hand side, you can see as a data, so we wanted to see the data view, right? So this is data oriented. It's quite similar. Data oriented design is quite similar to object oriented class diagram, right? Say someone tell me the difference between data-oriented design and object-oriented. That one, the static, the difference. Okay, good.
Data-oriented design, you can see the overview of data. And object-oriented design is more like objects and the relationship of objects.
Yeah, and data could be object, all right. So here, is it data. The one thing that's so here, can we see behavior, the method? Is your? I thought it just answers by you. Sarah?
Yeah.
Oh, answer that. Okay, all right. Go on.
Yeah, I think yeah, you can see the attribution.
Relationship.
Yeah,
Right?
relationship.
What kinds of relationship probably you cannot see?
Which data is this data is belong to this data.
Belong to. What it means belong to? Belong to.
Yeah. It's
If-
like
If this data belong to this, so what do you mean belong to?
it's like a fruit and apple. Apple is the fruit. I think it's this.
So apple is
A fruit.
a kind of fruit.
Yes, a kind of
Right.
fruit.
So how do we draw this apple and fruit? That's very good.
In here, how to say that thing?
Inheritance.
Yes, 继承.
Okay, inheritance. So which one? You can see that's very similar. Apple and fruit.
It's more like
Which one you can see?
object.
Here. You tell me that which one you can see that's apple is a kind of fruit.
Shorter
Inheritance.
design.
Which one?
Shorter design is the least, like the
Which one?
it's
You said apple.
and
Apple is a kind of fruit.
Yes.
All right. And which one? This?
it's more like
Middle or up?
I think it's here. This one.
This
yeah.
one. The, it's a fruit
Yes.
and it's an apple.
Yeah. I'm wrong.
So here top decider inherits from top manager.
No.
No.
Sorry.
It will be no. One. Right. Which one? You go to market, right? Which one? This? Inheritance, right? Inheritance here. So this is inheritance. So there is fruits, and there will be apple, right? Inherits. So you're going to see that, all right? So here, data-oriented design, right? Data diagram. That's then you cannot see it's the relationship of inheritance. That's so no inheritance. Data oriented. See. Okay. Other. Fine. All right. So, would you tell me it's about the difference between Scrum and stream programming briefly? Yeah, just the difference between Scrum and stream programming. Okay, second time. All right, you retake this course. You retake this course. Since you retake this course, how come? Raise your hand, you understand how to answer this. Okay. Narissa?
I think Scrum is focused on project management and teamwork, and the other one is focused on the code and programmer works.
Okay, if I ask you that, which, the answer yes or no, right? Both of the agile methodology, care about user, yes or no? Both of the methodology care about users.
Yes,
Okay, and actually, which one they can control their schedule, usually themselves.
I think it's Scrum.
Scrum, and which ones that the user play a very important role?
Important role, is it XP?
Why? Both of the methodology care about user's voice, but which one, user plays more important role? They can, make some decision. Harry, which one? Why? Uh-huh. That's my question. Yes, we know that's one. I said that they both care about user, right? They listen user's voice, right? And which team needs more involvement in the discussion or meeting? Which one?
Extreme,
Extreme programming?
yeah,
Why? Or what?
because it need to meeting every week and
Every day.
yeah every day and to
What?
they meeting every day and to
But but the members in Scrum also, they meet often. No.
no Yes, but it's not open to extreme programming.
Okay. Yeah, but not really. Penny?
The XP is two-person. They have high and professional to in the short time to solve the problem. So they also
So what?
so their meeting is just find the problem when they are programming,
Uh-huh.
and then another one is see the programmer. One programming, one see, and they find a problem. They can early solve the problem because
Okay.
they are professional.
Yeah, I talk about a pair programming, but that is not my question. Bridget?
Streaming programming is they meet with the customer at every meeting because the customer have to check the progress, and there's one thing to a customer can hold back because they are all high skilled professionals, and sometimes they will get wild.
Okay, good. Good. That's what I wanted to hear. Yes. Yes. So, customer trust the team, but they're afraid of to go wild. No, they like to do something new, right? So that's good. But they keep doing that. So it's going to draw back. Hold it. What we need is the other thing, right? They trust their ability, but to go wild, right? So yeah. So that's why customer plays an important role in that. Otherwise they would develop a very amazing project, of course. But part of that, based on their interests, they are going to, explore something, but they will go and control. Okay. So going to this process, data and process modeling. Let's say there are two schools, right? One is Gan and Sasong, and the other is Jordan, right? So we just saw Jordan, right? When you see circle, right? Circle is Jordan, right? You are not going to mix them up, right? Like you use circle and then mix with data store, like you have a close ending, right? Students, no, right? So use just one, right? And this book, right, the chapter I gave you, and use Gan and Sasong, right? So you're going to see like rectangle, but with a rounded area, right? And we have a line separate that because the upper part, we're going to have a number, right? Number to indicate that. And here it's a process, the most important one, because it's a process oriented, right? Apply payment. So apply payment. So you see that it's a process. This is a line, right? So here we're going to fill in the number, right? The number. It could be 0, could be 1, could be 1.1, could be this. The naming is very important, right? Because this is a process. You have to use the verb plus noun, right? Verb plus noun. It's a process. And process is Gan and Sasong, right? You wanted to process something, you need to have something, right? Have something. So that's the data, right? The data. So you need to have data, then we can process. Just like a bread box. As a bread box, we need to understand the process description. So we got to describe how to process this. We have the data from outside. I said only outside, right? So it could be a process. Another process, right? And two, probably other process, right? So per plus none, the same. And here, so this is data flow. Data flow. So you're going to see direction, right? So direction, you can see the arrow, it's the arrow toward this one, right? There's a data flow. Data flow, the naming, should be none, right? None. Could be plural or singular, right? Let's go singular. Singular or plural, right? Singular, plural. Data flow doesn't matter, right? So it's a singular or plural, doesn't matter. The process need to have inputs. It could be one input and one output. Need to have input and output. If only receive input, no output, then that's error, right? How come you receive input without produce anything? That's meaningless, right? So you have inputs and stop that. No, that become a black hole. Break. If pick it up, then that's wrong, right? We need to have outputs. So without outputs, black hole, no outputs. All right. If that is example, then this one's wrong. No inputs. That's impossible to produce outputs for your system, right? So this one become miracle. Miracle means without taking anything, then you can produce it. So it's a spontaneous generation. Right? Spontaneous generation is a miracle, right? It's a miracle without taking anything. Then you can produce. That's impossible, right? So that's wrong, right? If there's no inputs, it's only outputs. And here, you have an outputs. You have an inputs, no output. It's like a black hole, right? Or something that's on this is harder. That's you have inputs. You have inputs. And you have outputs. It's probably from the other. It is an external entity, right? It's the external entity. External entity, right? Inputs. Sorry. Oh, okay, I data store, but not sufficient to have this output, for example, right? It's a gray hole, right? Gray hole, logically, not sufficient for this inputs that can produce, need more, right? So you just see that the one inputs, no outputs, no inputs, or one outputs, or could be multiple, okay, multiple inputs, a single outputs, fine. Single inputs, multiple outputs, it's okay, all right. And here could be process to process, right? It could be external entity to the process, it's okay. Or process to data store, fine. How do they match? External entity, so singular, only singular, all right. Data store, plural. When you see it's not plural because it is a corrective noun. Corrective noun is uncountable like that, right? So that is a means of many, but use singular to represent it, right? So it's plural. When you see this as singular, it has a meanings of many, right? Corrective words. So all about that. So you're not going to have inputs or communication entity talk to entity. No, all right? Because we don't care about that, because external entity is outside of our system. So no, they talk to each other. This their thing. We don't care about that. That's wrong. You cannot draw that. You don't have the power, to draw the message set. And if we're going to send from external entity to data store, no. It's process oriented, right? Everything got to go via process, all right? So it's quite simple for that. Verb plus noun. External entity, singular. Data flow, singular or plural. Data store, plural, right? Or just look like singular, but it has the meanings of plural, right? Just that. Easy enough. This is it's noun, right? Services performed, right? It could compound, two words or even three words, but it's a noun, right? So one inputs, one outputs, fine, right? But if the inputs is not sufficient to provide outputs, then that's wrong, right? Single inputs, multiple outputs, multiple inputs, single outputs, and go through that. So that's correct. All right, and that part's not correct. I said that I cannot talk, between entity. That's not our business. Here, no. We got to have a process in between, right? The same for that. And the arrow, right? Three kinds of arrow. When we draw that, naming, right? How to name it is very important. And we draw that, we should follow two principles. That's another, in addition to the symbol, right? It's labeling and balancing, right? So it's going to see the labeling and balancing. Labeling. All right. So let's see that. Here, you have the diagram. The diagram is a higher level. You go to the lower one and go to the next level. So it's a labeling. All right. So layer and after layer and sublayer. It's a labeling. Balancing. So balancing, the words can be confusing, but balancing means that whatever your parent, like inheritance, right? Whatever your parents have, need to pass this on to the children. So children holds everything. So the parents is balancing. Okay, and there it is. That's. Guideline for drawing DFD, right? Do not cross line. Cross lines make it hard. You gotta have a jump, right? You might have this. If it's the same data, okay, fine. Spread it, right? You can spread it. But if you line, right, you wanted to cross another line, right here. You wanted to spread it across. No. Usually we're going to use a jump, right? So we jump this. You have a lot of jump. So it says, do not cross lines. Better not cross line. So you probably will see that if this one is 1.1, for example, and you're going to see the very end, you have 1.1. You don't want to cross line. It's fine. But we know that they are the same process. All right. So do not cross line because that would make the diagram hard to understand. All right. So usually you're going to see that a lot of jump. Then if you use the same, it should be same. All right. It is allowable. You gotta give a unique name and reference number. So this reference number 1.1, right, 1.1. Okay. The first diagrams of DFD, we call this context diagram. Context, right? Context diagram. Context means the environments, right? So when you see that environments, the environment is going to see external entity, data flow, right? Customer want to order, send an order, right? So you're going to see external entity, data flow, and the system, because external entity could be many. They receive outputs, they give inputs, probably no inputs, just receive outputs. I said probably because it's external, right? So probably, that is the sink, right? We send it to external entity. Could be a system, could be organization, could be anything, right? And we receive from external environments, right? It's context. Then we are not to have data store because data store is inside that. And the external entity, you see, this is symbol, but it is not a process. It is the system. So you got to give it a system name. So here, there's the context diagram. This is a system. So system give you the reference number, the 0, right? 0 means system name. All right, so here, grading system, it is not a process, even though it looks like a process, but it is not a process. It's the system. You are not going to see inside, all right? So no data store, no process. It's a system. No. So here, you can see 3 externalities and a system, the data flow. And also, you will see the data flow, the naming, no, because this is the top level context diagram. So usually, we will use a very broad name to describe its input. If the input has many, we use inputs or outputs, that's. If it has many, so this, no, but you probably, if the system need to send lots of inputs, then you don't want to make the context diagram very complex, and you can use outputs to represent, yes, we have output to this external entity. And external entity, if external entity provides a lot of inputs, you can also use inputs. All right, means we have inputs from that entity. All right, so not necessary to only have, 1, 2, 3, 4, 5, 6. Not necessarily only 6 input. Some of that could be, it's a compound. All right. All right, but here we know that the grading system has communication. I said communication means we receive inputs, provide outputs, that's. So students submits, input submitted work, got graded work, right? Like you submit to Chang class, right? So we have a grading system. You submit its work, and then give you graded, result. Instructor is going to do that. So I have grading parameters, right? Grading parameters I send to the system. So if this system is going to do its job automatically, right? So I have the criteria. Then it's going to calculate that. And the system, will give the instructor grade report, right? That's. And the result was sent to other, it's a student record system, that's, right? So you got the final grades, and this application, this system grading system, as class roster, right? Class roster, they have the class and the name of the students. That is the context diagram. Context diagram, we go to our real diagram, data flow diagram. So the first diagram of the system is diagram 0. The first diagram of the system, right? It's our system. We wanted to see, the communications between process. It's diagram 0. But inside the diagram 0, you are not going to see 0. Start from 1, right? So the left-hand side, this is context diagram. The right-hand side, start from 1, but we call it diagram 0. So remember, diagram 0 does not have 0. It's a 1, right? So the number that's 1, 2, 3, 4, and we have 4 processes. It's not necessary to put this as 1, right? You can put it as a 2, and you put it as a 1, right? So we have 4 processes, and here you should have data store, but not necessarily only 1. It could be more than 1, right? So divided, that's okay, and then we are going to decompose it, right? When we decompose it, is a labeling, right? If we decompose process 1, then it becomes 1.1, 1.2, 1.3, etc. We decompose 2, 2.1, 2.2, 2.3, until the end, right? Until the end. I said until the end. That means we go to the part we can write program, right? So it's a functional primitive. Primitive is the end. Functional primitive go to the end. That means, well, that's the end. We're not going to decompose it. So kind of, right? So here. Okay, let's take a break and continue study.